Hello everyone, welcome on board of our third workshop in a series of a Go Deep project entitled Managing Digital Intellectual Property in Manufacturing, SMEs Digitalization Process. Today we're going to talk about data-driven innovation and digital IPR exploitation. Here is some short information on the project that we are involved in. The project duration is 1 year. The partners in the project are Josef Stefan Institute Slovenia, Hub Innovazione Trentino Italy, InnoSquare Switzerland. It's a small-scale project in the scope of Horizon InnoSup program of €50,000. And the outputs of the project foreseen are collected digital IP best practices, scenario-based template contracts, models, and of data ownership. And most important outcome of the project should be so-called design option paper, which is kind of like a guidelines for SMEs how to handle their digital assets or digital data. This is, as I mentioned, third in the series of 3 workshops. Predecessing workshops were digital IP and data agreements. Then we had 1 workshop on legal aspects of digital IP protection and management. And I would just like to emphasize that one of the first outcomes coming out now are the results of a survey that we have opened for companies. If you're participants from a companies, please participate in this survey. It's very important. We're trying to assess how companies are understanding data processing and general understanding of companies of digital data capitalization. We're also trying to ask companies how they understand EU regulations on digital data. We will hear later on much has been done this year in this domain. We are asking questions of data storing, managing, and data exploitation and innovation. And some of the first outcomes are, for example, in the domain of how companies are familiar with the EU legislation. Not very much, actually. When we asked, are you familiar with the regulation on the free flow of non-personal data? 93% of the respondents said no. So very few companies are aware of this regulation. When we ask about Open Data Directive, which is one of the biggest directive coming out right now at the European level, majority of them again said no. And so we have a lot of work to do in this domain. Also in the scope of the European data spaces, again, very few companies replied that they are aware of it or that they understand the content of that. But I must emphasize that the sample is very small at the moment. So I'm encouraging companies again to participate at the survey. And another question as an example was, to what extent does your organization have experience with data-driven innovation? And a vast majority of companies said they have no experience. However, the trend is positive because a lot of companies said that they are considering a data-driven innovation, or they're already piloting or effectively even using some of them. We are coming from Josef Stefan Institute Ljubljana, Slovenia. My name is Bojana Omersel, and we're going to be co-hosting with Rudi, Panjtar, director of Strip Factories of the Future, this show today. We are a large research institution that has facilities in Ljubljana and at the nuclear reactor close to Ljubljana. We have about 1,000 employed people. 500 of them have PhD or scientists. Many projects on international scale, mostly in domain of nature sciences, physics, chemistry, automation, robotics, energy and environment. But we are also a member of many international associations, such as Liferay, I4MS, Vanguard, Spire, EU Robotics. And Josef Stefan has also international postgraduate school that starts this year with the new study program, Digital Transformation. So today's topic is really right on target in terms of where we need to head on with preparing companies for the new journey. Thank you so much for these introductory words. And now I would pass on the word to Rudi Panjtar, who will be facilitator today of this workshop. And of course, welcome on board also all of the experts and company representatives that will be providing us a meaningful insight. Thank you.
Hello, everybody. Thank you very much, Bojana, for this introduction. Well, today, this afternoon, we have agreed some very nice things together so that you will get insight in some very new things concerning the data and the business models. What is new is EU data spaces. It's a common European data space, a single market for data. As you have maybe read that the Data Government Act is released, and with this we can, Europe will get the very, very strong instrument to data commercialization and regulation. And this is that the data can flow within the EU and across sectors, availability of high quality data to create and innovate, and there will be European rules and values which will be fully respected. And there will be rules for access and use of data on a fair principle, practical and clear data governance will be prevailed. Regarding that, we will have different data spaces, and with these data spaces, there will be also possible combinations of these spaces and so on. And this way,
excuse me, Rudi.
There will be tools developed and standards regarding interoperability, technically and semantically. And there will be sectoral data governance with the contracts, licenses, access rights, usage rights. So this will put the data handling on the right way, that everybody will know the rules and how to use it, how to protect, and which tools are available. And I think this is the most, well, Europe is now a leading region regarding data, so that we are trying to establish this contra USA systems, which is a kind of hunting for personal data for the biggest companies like Google, like Facebook, and so on. But we would like to make the things European way and fair. So what is very important for us, well, I come from the factories of the future scene, and so this is manufacturing, and we are focused on industrial data space. So this is kind of a network of trusted data that you have seen here, and this can be a combination that some companies can share the data, and they can cooperate together also on a data way, and they can all make the profit from this. And for example, this is one of the examples. So this is a small company, and all of data which are here, data visualization layer, core data analytics layer, data preparation, and so on. So within this industrial internet system, you can get this data, and this is a kind of a small part, and all those small parts combined together can make a real system changer. And also there are new things with computing types. There are, as we see, that there was cloud computing was one of the several years ago invented. Now we have also fog computing, and we have edge computing. So fog computing and edge computing brings data more to the places where data are residing and data are born. And this way we can get faster responses, and also we have very distributed power, and we just maintain the data on the edge when we need fast results, real time, and then we have servers on the fog, and then we have data analytics and AI complications and analytics for whatever on a cloud.
Rudi, I'm sorry to interrupt you, but the slides are not moving on. Can you please move on to the next slide?
They're not moving on. Just
No?
sorry. It's
yeah, probably you have.
I will use this.
Screen
Better now. You can see that.
Yes, just use the screen.
Okay.
I see Bojana's screen, to be honest.
Bojana, did you stop sharing your screen?
I think so, yeah.
Well, do you see my screen now?
We can see the screen of Rudi now.
Okay, so
Industrial IoT data processing layer stack.
Okay, thank you. So this is a kind of industrial IoT data processing layer stack, as I have spoken before. And also we just got new things like new data repositories. So we are speaking about data lakes, data streams, and within this we have a lot of new things like transformations, collecting, distributing, publishing, and a lot of new tools available to gather this data and make value from it. And so the next and the last, it will be also, we will speak also about open source licenses like FOSS, free and open source software, open chain, and this will be done by the experts, which are Aleš Veršič, head of Open Data Portal Ministry of Public Administration Slovenia, Matija, Šuklje, lawyer, senior counsel at Liferay, Dr. Aleš Lipnik, Institute for Economic Research Slovenia, and Stefan Fischer, Euresearch from Switzerland. So this will be our agenda. I think we are some minutes late, but anyway, we will try to be as precise as we can. We will. I will give now the stage to the keynote speakers, and please interact. So please use the chat for questions and comments, or raise your hand during the interactive session of the workshop. You are welcome to do that, and because we have experts, and if you have any questions, please let us know. So now we are coming to the keynotes, and the first is Aleš Veršič, and he will tell us about the value of data in practical way with a focus on open data. Aleš, the stage is yours.
Rudi, thank you, and Bojana also. Hello to all participants and all keynote speakers. I'll try to share my screen now. Okay, share. I hope you can see my screen. And
Yes.
See. Okay. So we will try to talk about the value of the data, what we can do, and what kind of I will show also some examples using focus will be in open data, but still there is some potential also of the non-personal data in these cases. But first of all, I must say that now when we're talking about data and data governance and dealing all about the data, we can see now, let's say, three different approaches. One is the oldest one was, let's say, Silicon way, started in the United States, in the Silicon Valley, based on the approach of, I don't know, the Facebook, Google, and other these high-tech companies. Then during the progress, there is also, I would say, China way, full government control over the data with the social index and so on, with less, for example, maybe protection of the personal data. And then still, I think we can talk also about the European way, with, I would say, with high ethic value and the protection of the personal data. Talking about the European way, there is also some regulation which is regulating how can we deal with data in Europe. And I can also say that one of them, for example, GDPR, had also the influence not just in the Europe but also global. So this is the, let's say, the impact of the GDPR, which is dealing with, of course, as you know, with personal data. But in the picture, you can see the variety of the legislation which is already already accepted and it's up and running, or some in the progress. So I will start with the oldest one, dealing with public sector data. It's Open Data Directive. Before that was Public Sector Information Directive. Dealing for all public sector data, it should be open, of course, without any personal data. And after that, we can talk about the Inspire Directive. It's a special directive dealing with spatial data and the web services to give us the spatial data. Then we have also free flow of data. It's also dealing with non-personal data. So all of these three of them, Open Data Directive, Inspire, and free flow data, it's dealing with non-personal data. On the other opposite side, we have the GDPR, totally controlling what is going on with personal data. And then is some set of the regulations which is still in progress, or it's in the final stages. For example, Data Governance Act. It was, I must say, I'm very helpful. I was partly involved in that as a representative from the capital, coordinating the group of experts, helping our colleagues in the Brussels, during the presidency of Slovenia, finalizing the Data Governance Act. And also, I must say, thankful for to colleagues from the Portugal, because they started the whole process, and the first draft was published for the Data Governance Act last November. So in 1 year we go all through all these procedures. Now it's the final stage, just to go through the parliament. A few days ago, colleagues from the Brussels finalized the political trialogue with the Commission and the Parliament, and it was successful. So they achieved some agreement. It's not official, but still they go through all these open issues. And it was also the base for the next act. It's Data Act. It should be published next year on February. The first draft, and this Data Act will dealing with more private sector data. So we are going from the public sector to the private sector, because there is also quite a lot amount of the data inside the private sector, and to have us to be a better digital society, we need to also share all the access to this, handling this data, and also the Digital Market Act is some part of the also dealing with some data. Maybe I will just show you some focus on the Data Governance Act. Why this is important? Because this act will enable public sector to making more available some protected data, such as micro-statistical data, some personal data, in the way like already now the statistical offices in Europe are dealing already. But it will be raised in the next level, let's say, in the all public sector. So not just in the statistical world, but also the all public sector. So each country should establish the system where can the researcher access to the personal data or the protected data. They do some analysis, some everything what they want to do with data, and then there will be some commission which will overview the results of this data, if there is still any personal data or not. So it could be published as open data, for example. And some of this kind of the system is already running in France. It's called Center for the Protecting Access. Also in Finland, they call it FinData, and in Germany, they already have this kind of the system. In Slovenia, we need to establish, I don't know, for the other countries, but these three was also examples in the impact assessment study about this Data Governance Act. Also, another important issue, especially for the private sector, is this act will making more easy sharing the data among businesses, business to business or citizen to business, because it will establish the data sharing intermediary, the companies who will be middleman between two companies or citizens and companies, and these companies, the data sharing intermediaries will prepare all the necessary legal and other issue about to exchange to share the data between these companies. And also one which is also important, it's called data altruism organizations. So the purpose of that is for every citizens in the Europe can share his data or her data to some researchers, and it could be done through this data altruism organization. This will be like if you have data sharing intermediaries for the private companies, data altruism organization will be in the same role between citizens and researchers. So it will prepare everything, all the paper about the consent and so on, and all collecting the data. The idea of that was the problem which they had in Germany, Robert Koch Institute, during the COVID. They wanted to receive the data from the smart watches about the temperature of the people. So it was quite hard to get all this kind of data, but they could use this data for the tracing the hotspots of the COVID. So this was the idea. So this data altruism organization is something new in this Data Governance Act. And these data sharing services will be a key role of boosting the data economy in the Europe. And also the Data Governance Act also enabling to create data cooperatives to make some small companies create data cooperatives, and they can together be some part of in the negotiations or something like that. So maybe this is like something which is important in the Data Governance Act, and now I will share you some also examples from Slovenia using, let's say, for open data. One is it's called application called Autolog. They're mostly using the data from the technical review of each car in Slovenia, which is you should do for the car which is older than 4 years. You must then between 4 and 8 years you should do this technical review every 2 years, and after that each year. And the results are published in our open data portal. And why this is important? For example, you can see here in this picture an example when the user of the car make the kilometers of the car going down, so downgraded the kilometers. So the value of the car is now higher, and the buyer who buy this car will have a problem because they don't know the real number of kilometers of that car. And also in this data, you can see some examples from the technical review of this car. So this data could be also used in the companies who is producing the car. I know that some companies already receive the data when you go to the yearly services of the car. They can download all the data from the telemetrics in the car. But still, there is also once in a year, or depends how old is the car, you can get the information about the technical review of the car. So this data is also available. And what is ID of this data is VIN number. So it's vehicle identification number, which is unique. And you can also, in this application, you can put in this VIN number. So you can check if the car, if you're buying the old car, the data is real on the day when you're buying this car. Let's say, what is the possibility to use this if you get the data from the all European countries? So you can create, I don't know, the European app, so you can see the history of the car. We had a problem, for example, a lot of the cars in Slovenia, the old one, it's imported from Germany, Netherlands, Belgium, or Italy, and it's very important to see how many kilometers was in Germany from day one, which was the user started using the car. Another example is combining 3 different sources. It's from our local in Ljubljana system of the public transport. Then also we have some the blue dots. It's a location of car sharing. So with a view of the mobility, you can see here the data from the private sector, and also the parking places and the places for the bicycles is already here combining with the public sector information. So this is using if you want to go from point A to point B, you can choose which kind of the transport you will choose. Also, example, using the public sector data for the COVID, it's COVID-19 Lipnik. It's created by community. They're using all public sector, all available data, and they are a source for the many other users. And maybe the example which is important, we have also published the data from the sewage system, and because our Institute of Microbiology checking the presence of the COVID in the sewage system. So they can detect the presence of the COVID at least maybe 2 weeks before it's spread widely. And maybe for the end, because I think the time is quite not friend of us, I would say that data is a reusable raw material, not oil. Sometimes people said data is the new oil. I would say it's a reusable raw material for the new products. Using open data, it's making data usage more easy. Very important to share the data for the new knowledge. What is the case is we have using open data, it's accessibility of data, because sometimes the data is available, sometimes not. So if you're creating the business, could be some problem about that. Also, the best solution is to have API access to the data. And what is important, especially we are talking about the industry, ownership of the data. For example, I would give 2 examples. If I buy a car, is the data which I produced by this car mine or not? Or if I rent a car, who is the owner of this data which is produced with my driving, because I create this data. So this is, I think, the issue which would be also, I hope you will have possibility to deal with this during your project, especially with the lawyers, because this is, I think, it will be the key issue in the future, especially in the digital society. And what is important that, especially public sector information, that everyone has the right to use the data under the same conditions. And important also, the data is not free. Creating the data, it's not free, but only the reuse is free. So I would stop at this point, and thanks for your attention.
Thank you very much, Aleš, for your presentation, and for your really fruitful examples of using the public data and combining with private data. So when I think on open data, I see your picture, because you are evangelist for this area for certain years, and I recognize open data as a synonym for Aleš Veršič. And I have a question for you. So what legislative measures on data governance, access, and reuse data were adopted or planned in legislation in Slovenia?
So currently we have all other these acts which are directly implemented by the some law, but for example, Open Data Directive was transformed with its law about access to the public information. It's the new version of Open Data Directive. It's still not implemented in Slovenia because we have some issue. The new Open Data Directive also bring us a new terminology. It's called high-value data sets. It's a sixth area. It's geospatial data, observation, and about environment. Then it's meteorological data, statistical data, business register, and mobility data, which would be available only also through API. So access to the data, it's through APIs. It's the future, and the legislation is also bringing this to us.
Okay, thank you. So we are going to the next. Just to share. The next comes Matija Šuklje. He's a lawyer, a senior counsel at the Liferay, and he has a lot of experience in free and open source licenses. So he will just explain us about free and open source licenses for SMEs, from basics to the how can we use it, how can we maybe monetize these licenses, what we can do, what we cannot do. So Matija, the stage is yours.
Thank you. Okay, let me just see how I can share that one. That's the one. Okay. Can you see the presentation? Perfect.
Yes.
Okay, I suggest we just dive in because this is a very complex and big topic, and I might need to speak fast to get us through it. I'll be open to questions even later on. So first of all, if we're talking about open source license basics, we need to figure out what licenses are and why we need them. And here, as we learned previously in this session and in the previous sessions, is that copyright is automatic, and all the intellectual property rights are exclusive rights. So the one who owns them has the right to do whatever they want, and then nobody else may, apart from if there is an exception in law, which, spoiler alert, when it comes to copyright and software, there's very, very few exceptions in law that help you. Or if you have a license. So a license is, by definition, a group of rights that the owner of those rights gives to you that are more than what the law gives to you by itself. So the big two groups of licenses I would like you to think of is the inbound license. So those are the licenses, those are the rights that you get from your upstream. So from your suppliers, from stuff you downloaded online, etc. On the other end, you have the outbound licenses. Those are the rights that your entity gives to your downstream. So to your customers, to the general public, whatever you choose. And if I talk about open source, I use the term free software open source, FOSS, interchangeably. But what it's important to notice is that FOSS means FOSS, not FOSS as in free as in beer, but free as in freedom, which brings us to the basics of free software or open source software, which is that every open source license, and I emphasize again, every open source license gives you the right to use the code for whatever purpose you want, to study what the code does. So you need to have source code to do that, to share the original code that you received, and to improve or modify the code that you received and share that with your downstream. If you decide to, it's a right, it's not an obligation. So those are the four things that every open source license gives you. Why you should use open source in your organization? Well, basically everybody uses open source by now, whether they acknowledge it or not. The two biggest reasons are obviously because it's cheaper, because you're reusing already tested and existing technology, but also because it's cool, because the kids use it, they learned they learned coding on open source, they contributed to open source projects to kind of make their CV. That's how you attract talent. That's how you train them to use your technology, and that's how you keep them later on as well. So if we have an inbound set of rights and we have an outbound set of rights, we need to make sure that they are in between, they're compatible. So why do we care about what we call open source compliance or licensing compliance? Is because that's the bare minimum legal requirement you have to do. Not only are you violating the license, if you're violating the license, you have no right to use the software, so you're breaching somebody's copyright, which can have civil and criminal repercussions, and also often has reputational damages. And probably the most problematic of them all is that suddenly you're not allowed to use the software you used, in some cases forever. So in an example of the GPL license, if you breach the GPL license and you didn't get all the rights back in time, then you are not allowed to use that piece of software ever again. So there are some, we could go like into detail. There are a lot of different licenses. There's like hundreds, thousands of open source licenses out there. And there's a lot of different things and different obligations and different pieces in there. But some common things that if you follow these, you're like 80% okay with everything. And for the remaining 20 or 10%, if you have these in place, those 10 or 20% are easy to manage. If you don't have these in place, those 10 or 20% of special cases are very hard to get right. So as I said, it makes sense to have your, the inbound licenses compatible with the outbound licenses. And how that works is, or what are the details there, is outside of scope for this quick discussion, introduction. But the important part is that you need to keep all the license text in place, and you need to keep all the copyright notices. So when you ship software that includes open source software, there need to be, the license text and copyright notices that were in the code, they need to stay in the code. Just don't take them out. It makes a lot of sense to also store the source code for the specific version that you used of the package, as well as log any modifications you made to those packages and mark your own work appropriately. And while we're at the compatibility question, it also makes sense not just to make sure that you're compatible legally, but also that the licenses you are using are okay to your downstream. So if you are using something that you are okay with when it comes to legal obligations, but your customers may not be, then you're just not going to have customers. So you need to take that into consideration as well. And last of all, it's not a big obligation, but it makes life a lot easier, is to list all third-party code and information about it. And there's some tooling I will mention in the next slide deck that helps you with that. So try to automate that as much as possible. Manually, it's just too much work. Here, I would like to point out a distinction between whether something is a derivative work or not. So this is legally speaking, this is a complicated question, especially when it comes to software. But a simple rule of thumb is that if you call a runtime command, for example, through a command line interface, and it runs in its own process, then that piece of software, so that open source package and your software are not interacting in a way that you could call your software derivative or a modification of the original open source package. And the same is true for web APIs. So if there's a web API as their interaction, there should be no problem. On the other hand, if you are linking your software to an open source library, it could be a derivative work, and it especially very much likely is if you copy paste parts of somebody's code into your code. In those cases, you need to make sure that the licenses are compatible. Then another big question is whether it's a distribution, and because a lot of copyleft obligations trigger on distribution, so on the actual act of copying the code or binary. And very simply put, like if it's a desktop application, mobile application, even if it's over their updates or it's embedded, for example, like software inside a smart speaker, those are all classic cases of distribution. But software running as a service, so if you're running software on a server, the end user is not using the software, they're not getting copies of the software, they're just using the service. So in that case, it's not a distribution apart from browser-based, browser-side JavaScript, because your server serves JavaScript code to the browser, and that also counts as a distribution. So some details I'm going to look into right now, and this is like the most complicated slide in my whole presentation, but it's super easy to understand once you figure out what it means. Sorry. So at the top, we have like the proprietary section. So copyright, like full-on copyright or end-user license agreement. We have the open source section and the public domain. And then here we have the 4 freedoms. So to use, study, share, and improve. So if we look at a situation from the pure copyright perspective, it's just copyright law, there's no licenses attached. If you somehow legally obtained a piece of code, you may use it, and there are some limitations of how you may study and improve, but don't and change the code. But those are like very, very narrow exceptions in the law. And because it's copyright, the owner reserves the right to copy. So in the situation where in the whole graph, the number 2, so the square, is the organization we are. So the organization we are looking at. So in the first column, we have our inbound situation. So we got a piece of software from our supplier or from an open source project. And in the second column, we distribute our code together with the original code to our downstream, to our customer, for example. And in the copyright situation, because we do not have the right to share, we also do not have the right to give anything. Like we cannot forward the rights to the software we obtained to our downstream if we do not have the right to share it in the first place. So if we look, on the other hand, if we look at the same situation in the proprietary, in the permissive open source, also sometimes called lax, open source licenses, we get all the 4 freedoms. So we got the right to use, study, share, and improve the code we received. But we have no obligation to forward those rights. We can if we want to. We can give the same rights to our customers, but we have no obligation to do that. It's similar in public domain if perchance we find any code under a public domain license in public domain. So examples of permissive licenses are like MIT BSD licenses, Apache license, Creative Commons attribution. And then on the other hand, if we look at copyleft licenses, again, we get all the rights. And we are obliged to give all the rights also to our customers. And typical representation here is the GPL, a Faro GPL, European Public License, and Creative Commons by share alike. So the difference between strong and weak copyleft license is what the scope is of the code that we need to forward the rights to study, share, and improve to. And for example, when it comes to GPL, when it comes to strong copyleft licenses, we need to give forward the same rights or keep the license to the whole work, which may include a lot of our code as well. And what a work is where it gets a bit interesting when it comes to the cross-section between technology and law. And when it comes to weak copyleft licenses, the scope is narrower. So for example, in LGPL, the scope is we need to just keep the license and the rights to the library we used, to the open source library, but not everything else around it. And with Mozilla public license and Eclipse public license version 2, the scope is file-based. So just the files that are explicitly declared to be under those licenses need to be shared under those licenses. With SaaS, if you run software as a service, things changed in the sense that pretty much all of the licenses moved to weak copyleft. So what that means is that because no distribution is happening, a license has to have an explicit new clause in there to trigger the copyleft effect. So to force you to give the four freedoms also to your downstream. And in a network situation, this is only true for a Faro GPL open source public license, which is not super popular. And I think the newer version of European public license. Every other license, if you're putting into a SaaS context, does not trigger copyleft effect for the end user. Like 2 minutes on patents, and then I'm going to be done for this slide deck. Patents per se in software should not exist, but in practice they sometimes do. So some of the open source licenses include a patent license. So which means that if anybody who contributed code or gave you distributed a package to you under this license also gives you the patent rights to use that piece of software. Most often, this is limited just to the use that is necessary to use that piece of open source software. And anything outside of that. So if you, for example, if you got a driver for a piece of hardware that's under an open source license that includes a patent license in there, like under Apache 2.0 or under a GPL license, you would not be in breach of the manufacturer's patents if you use that driver on your machine. But even if you downloaded the driver legally and you started making a competitive hardware, you would be in breach of their patent rights through that. Often these licenses also include the so-called patent retaliation clause, which means that if you sue somebody over a patent that you hold for a piece of software that's under for example, Apache or GPL license, you will be the one that loses the right to use that software from every other developer automatically. There's very few licenses that do not have anything to do with patents. So Creative Commons 0, I think, is the only one that I can remember that explicitly does not include patents. A lot of modern licenses have an explicit patent license so that it's actually in words what it means. Some older licenses, especially the MIT and BSD era, have what we kind of call a somewhat implied patent license. So they use patent language. So a reasonable legal interpretation could be that they also include a patent license. There's two patent protection schemes I ask you to look into. They just protect their members from patent trolls, and the OIN and lot network are complementary in this case. So they both cover a specific use case that they complement each other here. So if you're worried about getting sued by patent trolls, those two are probably something you might want to look into. And that's it. Thank you.
Thank you very much, Matija. It was really exciting presentation, and for opening the heads where in how we can use the FOSS, free and open source licenses, and what are limitations. And normally I have a question for you, two questions. First one is, for example, in USA, you can patent programs and algorithms. How is this regulated when, for example, one piece of source code comes to a company in USA and they just make a patent on an algorithm which is then in a code, and then it is a kind of a privatization for the previous work done. How this is tackled? Could you explain that?
Could you repeat the question? There was an echo and I didn't hear you.
Yeah, well, in USA, you have ability to patent the algorithm and patent the programs. And for example, if there is a company and make a piece of code and add this piece of code and patent it, and what is the result for the previously maybe public code, then becomes a kind of a private code, and with all the patent liabilities and licenses, whatever. How is this tackled?
Outside, if we skip the patent protection schemes of OIN and LotNet, first of all, if the algorithm or the code was publicly available before, it could be possible to, so that in that case, the patent shouldn't be valid in the first place because it's not a new invention, because it was publicly known before they filed for a patent. In case they did file before they published the code, if they publish the code under an open source license that includes a patent license, this should be fine if you use, if your software bases on their software. Ultimately, also, if they still sue you, for example, and again, assuming that that's an open source package that includes that that algorithm, then that might be covered by Open Invention Network's definition, if you're a member of that, because it includes a lot of open source packages. On the other hand, it's also, the question is also, I mean, patents are also territorial. So if they manage to register it in the US, it doesn't necessarily mean they might be able to register it elsewhere. It might be easier because they already have a patent somewhere, but it's not automatic. So as long as you don't breach that patent in the territories where they have a valid patent, you should not have an issue with it. That's the theory.
Okay, well, the second question I will spare for the next session when we will have you on the stage. And there is a question from the public. Do you feel that investment companies' funds are moving to a more aware consideration of the potential of open source based business models? Do you have some hints for a small company willing to work with open source?
Yes, I do. This is something we're gonna briefly discuss or concentrate on in the second part of the discussion. But yes, I see a lot of, although with investment companies specifically, so if we're talking about venture capital, I think venture capital is still catching up. I think I see I see a lot of venture capital currently, especially in the database sphere, use a kind of a bait and switch trick. So what I see happening with venture capital is in the past few years, they started heavily investing in popular open source databases. For example, we can think of MongoDB and Redis and Elastic. And once they figure out that it's so popular that they want to cash out, they change the license from an open source license to something that kind of maybe looks like it could be open source, but it's actually not. I was involved in quite a few very, very heated discussions about the classification, whether the new licenses of Elastic, Mongo, and Redis were open source, and the conclusion is they're not. So this is my fear, is that at the moment, venture capital specific, and it might be that it's specific venture capital companies that do this, are doing this bait and switch technique. But I see a lot of major companies that actually do things, very invested in funding open source projects or making their own software as open source and collaborating with others. So this is what that means for non-venture capital investment companies and funds, I don't know yet. So that's a place I'm currently blind at, I'm afraid. I hope that helps in any way.
Yes, I hope all the best for the future for this not to be privatized. And so thank you very much, Matija, for these answers. And I will introduce the next speaker. And the next speaker is Dr. Aleš Lipnik. He is a professor on many faculties, and he is temporarily employed in Institute for Economic Research. And in his career, he was dealing a lot with innovation and also technical transfer and so on. And I know him for certain years, and he will give us some information and overview about data-driven business models. Aleš, the stage is yours.
Thank you very much. Just a second to share my screen. I hope it's okay.
Yes.
Okay, thank you again. Let me take my presentation. Well, when we about 10 years ago start to talk about Industry 4.0, we didn't be completely aware that how much this will depend on data. Now we can put equal mark between Industry 4.0 and dependence of data. So when we are talking about the data-driven business models, we actually trying to creating some value from data, because this data becoming a core challenge for companies. And in the Industry 4.0, actually, we are trying to get some revenue from this data. So to create competitive data-driven business model is actually the main task for the companies in this era. And this data affecting actually all dimensions of this business model, starting from the value proposition, of course, to the value added, and in the final stage to the revenue model. So, focusing on data, we actually became not only key resource for our production process or marketing process, but also for the complete business model of the company. Well, if we are talking about some facts, we notice in the few years that amount of data created by the new technologies growing tremendously. And all technologies arising gives us a lot of opportunities for generating a massive amount of data via different service, different sensors for different purpose. And stepping back to the, let me say, basic of the information technologies, core activities of DDBM are data acquisition, data evaluation, of course, data use. So these new and different data solutions we could provide to our customers, like monitoring process, diagnosis, predictions of some process, or maintain some products, machinery, etc., means actually new value proposition. And this value proposition and value added, of course, become the core element of new business models. So the crucial question for the company is how we can use these new technologies, and of course data connected with this, to deliver data-driven services, and how to create a new business model. Actually, there are two sides of this coin. We are facing quick technological development. And this quick moving, quick development requires permanent monitoring and, of course, evaluating all existing technologies about the possibilities which could be related to DDBM. On the other side, as a result of this monitoring, we also have a demand for quick response in order to implement these new data services, or of course, improve the existing one. So, when we are starting to develop our DDBM, we have to answer a few basic questions. Starting with the data. How valuable are actually my data? And of course, from the perspective of businessmen, how much can I make of it? And the second question is, do I have right to use this data? Are my data sensitive? In which form are sensitive? And can probably not be used, or can be used, of course. Of course, this shift from non-data services or products to data center view is actually a core business of digital transformation. And regardless to value proposition, value added, focusing on data, actually affect all segments of existing business, not only technological one, but also company culture, existing process, resources, costs, and of course, a revenue or services portfolio. So when we somehow answered this first question, we can start with the development of our DDBM. And which are these steps? First of all, we have to identify and evaluate technology trends and prepare some kind of action plan of its application. Second, very important step here it is to analyze our preparedness for adopting DDBM. Are we prepared? What this will mean for our current organization, company? Do we have enough knowledge? Not only technology. Third point is, of course, developing and evaluating our data-driven services. Connected with them, very important steps is also to select data for these services. And of course, we have to clarify the questions arising about the use of intellectual property rights in our new business model. Last but not least, we have to develop and validate our new business model. Talking about the IPR, actually, maybe one of the most attractive questions for a few years now is actually, can machine-created inventions in IP acquire a property rights? To answer these questions, actually, we have to ask ourselves what actually is purpose of IPR. And of course, what is this? This is to keep your business away from competitors. Should be licenses, should provide some revenue. And of course, it have to present something new and different. Not at last, IPR is important part of marketing or branding process. Somehow, until now, it is believed that creativity and innovations or complex solutions are actually a result of human intellect or human mind. Of course, within the Industry 4.0, we are facing many solutions based on the artificial intelligence, which becomes more and more human-like. Artificial intelligence is capable of learning, becoming more and more complicated, more intelligent, and is capable to make a complex decision. Therefore, the question is, if we want to protect the value of intelligence, we must somehow recognize artificial intelligence as being capable of owning intellectual property. However, consequences of this in the society is very unclear. Why? Because at the final stage, human has to derive some revenue or some beneficial of this right. Well, in the words of the WIPO General Director, what's next? He said, it still remains unclear how effective the classical IP system will be in addressing all of the issues arising from the data-driven technologies that dominate in the digital economy. Undoubtedly, this will pose significant challenges for IP policymakers. So, regarding to WIPO, which are these steps for the policymaker. These are actually to define appropriate and legitimate practice with respect to collection, storage, and use of data. To identify restrictions, which restrictions are appropriate for the collection, and of course, subsequent use of this data. And we need to understand or have some, let me say, common agreement why these restrictions are necessary. Exceptionally powerful means of collecting data of all types, like voice, text, image, exist. We still need to identify appropriate means of collecting and using of those data. So which are the factors which coming into play when we establish possible restrictions? On the first place, there is privacy, of course. We already have some regulations, starting with GDPR or Declaration of Human Rights. On the second place, there are restrictions or connected with the security, taxation, how to track translations. Data are not know the borders. Actually, it can be captured in one state, processed in second state, and let me say services provided by the third country. So who has the right to tax is another question which have to be somehow solved. And of course, property and intellectual property, because ownership or property of intellectual properties is still one of the basic form of or meaning of the protection. Actually, currently, trade secret is dominant mean of protecting the unpublished data in digital economy. However, some research said that not only trade secrets, but also patents is also very strong form, which is applicable IPR in the data-driven business model, because somehow hardware still have a key role in capturing the data, and it's this data-driven business model is based on these sensors or some hardware who capture the data, and this hardware is protected as a patent. On the other side, as mentioned before, trade secrets are also seen as a strong complementary tool to other intellectual property rights like copyrights, database rights, or patents. So here is my point of view, here is my 5 cents, let me say. Thank you very much.
Okay, Aleš, thank you very much for your presentation. I think you have opened some interesting questions which we are not able to answer yet, and they are quite. There is quite a debate about the things you have opened. So unfortunately, you will not get my question now because we are a bit beyond the schedule. So I will spare my question for the second part. And so I will now announce the next keynote speaker, and he's coming from Switzerland. Stefan Fischer comes from Euresearch, and he's also a national contact point for Horizon Europe in Switzerland, I have read. And Stefan, please, he will tell us about getting value from the patent and data portfolios, which is very interesting subject, and I think you will enjoy in his presentation. Stefan, the floor is yours.
Thank you. I assume you see my presentation in full screen mode. Is this the case?
Yes.
Great. So I will not answer this first question. This is just for me to find the right, hang on, the right slide. What I'm speaking today is getting value. Is about getting value from patent and data portfolios. And I start with asking a question. When in about 2015, there was this hype. Every journalist was speaking about 3D printing, and it was everywhere. So why I may ask, was this such a hype? And at this particular stage in time, 3D printing technology was actually already a mature technology. It existed already for 10 years, but nobody really used it. And why was that? The answer is between 2013 and 2015, some critical patents about 3D printing technology expired, and that allowed people to really build 3D printing devices and bringing them to market. So why was having patents so useless? Because nobody bought these licenses that were available. Well, they were not available because nobody could buy licenses because they were so distributed among so many patent holders. At the same time, these patent holders couldn't make any income whatsoever because there was no way of shopping around to dozens and dozens of patent owners to buy these 3D printing licenses. So that was a failure. Now, an example where it worked a little bit better is MPEG-4. And if you have watched a video recently on your browser, you most likely have used the MPEG-4 video coding standard. It's a very complicated standard that uses motion estimation, discrete cosine transform, predictive coding, and I could continue for hours. It's a very complicated thing. And many companies actually contributed to this MPEG-4 standard. There are some big players, in most of the names you probably know. So can you imagine to shop around with each of these individual patent holders to buy licenses? No, it's not possible. You would spend time negotiating licenses without actually being able to build or to develop an MPEG-4 encoder. So what happens? What they did, they actually created MPEG-LA, a company that sells licenses from a license package. So actually, you can buy, if you are a manufacturer and want to integrate this codec, this video codec into your device, into your machine, you can buy a license, one license that brings all these patents together in one patent portfolio. And it was a success compared to 3D printing before 2015. Now, and a last example, hard disks, and you know this this image in 1956. The first hard disk was 5 megabyte with a 5 megabyte capacity and was weighing a ton or so. So you had to bring a forklift to lift it into an airplane. That changed in 2004 with the Winchester hard disk. Well, before that, but this is just a very miniature disk of IBM, which wasn't a success, but never mind. And finally, today, I could buy actually a hard disk with 18 terabyte. Now, one company that actually succeeded in monetarizing a patent portfolio, sorry about that. I just have to give me just a second. Yes, can you see this? Pabst licensing actually was founded by Georg Pabst. He was forced actually to sell a company that his father founded, and he did something very strange. He said, I now I have some money. I sold the company, but I back the patents from this company. So he bought back the patents, and these were critical patents that every hardware manufacturer in this world had to violate in order to build these new hard disks. So he relentlessly attacked all of these manufacturers and cashed in quite an amount of money just based on this very valuable patent portfolio that he bought back from the company he just sold. Okay, what can we learn from these examples? And there are a few things that we should summarize. A patent portfolio has a monetary value. It can be monetized through licensing, or we can sell parts of it, or even, let's say, equip a startup or a new spin-off or venture with new IP. And everything I can tell you about patent portfolios has already been presented in this article already in 2010 by Nathan Meerwald, who happens to be the founder of Intellectual Ventures, basically a company that does nothing else than building patent portfolios and selling them and selling licenses for that. Now, of course, this was a company that was founded with $5 billion, and it's now really the biggest patent owner in the whole world. And let's see, what else can I tell you about patent portfolios? Just give me be patient because it's very advancing very, very slow here. So a patent portfolio is worth more than the sum of its parts. Why? Because with a large number of patents, a patent portfolio it's very difficult to actually circumvent it. And even if some of the patents are invalid or expire, they still can, the value of the patent portfolio is still there. Now, another feature of a patent portfolio is its averaging risks. You can imagine that a patent, we never know if one single patent is valuable in the future. We can only assume, and we can average this risk of a high payout. Let's say it's not a risk, it's a gain, but we can average this by building a patent portfolio. And insurance companies are basically doing this routinely. They deal with low probabilities of high payout events, basically. So not knowing which of the patents is actually really valuable is not a big deal if you have a portfolio and you know among those patents in a portfolio a few are valuable, or even one that could be interesting enough. It's a waste of time to sell individual patents. So how to design patent portfolios, and some guidelines could be, well, not only, but you should probably choose a growth industry. You should cover an entire value chain. Then you have really a vast protection. You must, and that has been stressed in one of the previous talks, you must develop a suitable business model for the licenses. And you must establish a sales channel for the licenses. Without being able to sell it and someone to buy it with a fixed price, patent portfolios will not succeed. Now, another thing that is very important and is often neglected: patent portfolios are also financial instrument. What is a financial instrument? It's an asset that if you put in money, you can increase its value. And patent portfolios the value of patent portfolios can be increased by the purchase of additional patents, by development new inventions, by commissioning contract inventions, or by license agreements. Because if you have license agreements, the value of the patent portfolio automatically increases. And having a financial instrument is actually something that we. Sorry about that. Having a financial instrument, of course, why not make this financial instrument into an investment instrument? And that has been tried in Europe. And while Intellectual Ventures in the US was so successful, patent funds in Europe have failed miserably. Why? And I think the main reason is there was never a portfolio strategy. They tried to sell individual patents and forgot the the portfolio strategy that is actually necessary for these funds to succeed. Now, what we learn from universities, it's a similar case. They do technology transfer. They sometimes sell the licenses of patents to the inventors, that meaning researchers or PhD students who then found their companies. This is completely okay and legal, but there's usually no portfolio strategy either, no proactive let's say development of patents to develop portfolios and to increase the value and to create gaps or to fill gaps in the patent literature. And whatever I said about patent portfolios can also be said about data portfolios, a collection of data sets. I've spoken with a company recently in the French-speaking part of Switzerland, and they asked, how do you protect your software? Because they have developed a software that, or a system where I can send an image and they do provide the analysis results. So they told me, no, we don't protect our software. We don't have patents. We do everything on our server. So clients only send their image, we analyze it, and we send it back. There no object code, no algorithms to ever leave the server. However, what this company has, of course, is a very, very valuable database. So putting that together into a portfolio from another company would increase the value of this data set significantly if they decide to sell it in some way or the other. Now, what is the summary of all this? Well, I have two recommendations. SMEs should think in terms of patent portfolios, not only for their own value creation, but as a source of income, because they could sell the invention for entities that collect patents into patent portfolios. Universities should create value through strategically developed patent portfolios, again, instead of just selling licenses of patents to those people who have invented it and now funding their startup or their spin-off from the university. So we should seriously consider establishing a European patent fund. It's probably not too late. And that's pretty much all I have to say today. And of course, you can contact me anytime by email, LinkedIn, and for those in Switzerland, you can contact me at Euresearch if you have questions about European funding opportunities. Thank you.
Stefan, thank you very much for your presentation. What you have mentioned the most is that you have to have the portfolio strategy, so for the patents and also for the data. And that is, I think, your key message you have given to the listeners of today's presentations. And because without the strategy, you just have like you said, a bits of information, a bits of licenses, which are not so powerful when you combine it as one portfolio. So thank you very much. You will not get a question from my side because we are late, and I'm going to the next part of the event, and this is the company perspective. So today we have 5 companies, and we start, and all those companies are using data in their business models. And we start from the first one. It is company Salesqueze from Slovenia, and we have online the CEO, Leon Panjtar. And please, Leon, the stage is yours.
Thank you. Welcome to everybody also from my side. I'm honored to be invited to present what we do at Salesqueze. And I also would like to thank all the speakers that came before me. I found out some really good information about the general approach to using data for commercial means. Okay, I will just share my screen. Okay, can you see my screen?
Yes.
Yes, okay, great. So maybe from the company's perspective, so we're a startup from Slovenia. Our main focus is helping manufacturers reinvent B2B sales. We focus on configurable and complex products, and we are pretty externally focused. So we help companies establish sales channels along their entire B2B networks to offload the work from the company itself and distribute it through the entire network. So this is an initiative that we started developing 3 years ago. We currently have around 50 customers. We started moving from Slovenia to other markets. We're currently present also in UK and are starting to expand to Germany. So why configurable products, and most importantly, how does data come in the business terms? So I'm going to be quickly talking or walking you through a few challenges, few solutions, and a few interesting results that we kind of figured out along when we were researching the area and developing the opportunity. So I'm going to show you a brief look into the complex and configurable ordering process, and then we're going to talk about a little bit of the sales and material flow forecasts that come out of this entire global operation of a company. So the challenges, we actually started solving the challenge for several companies that manufacture and produce configurable products. And while we were doing that, we actually started seeing some interesting patterns emerge. So most of the companies we work with that have a global B2B network are capturing really a huge amount of data. So if you imagine a configurable product, probably the most common thing that comes to mind is a car. So everybody probably knows car configurators. And if you think about all the options and configuration that you have available in a car that is, available to choose when you are buying a car, it's really a massive amount of different variations. So I'm going to show you just first what a configurable product is. We actually call configurable products with many variations, products with configurable bill of materials, or in some cases also abstract products, which exist in the mind of the customer but don't actually are not actually sold as a product. So typically it's a furniture equipment or something like that. So the common thing to all of them is they are really hard to understand from the customer point of view. So the customer needs to be guided in order to find the correct solution for his problem or for his wishes and desires. And this task is usually completed manually by the sales department in the manufacturing company or their B2B dealership somewhere around the world. And also another property is that products are usually ordered with their bill of materials. So the order is not a single item, but it actually consists of a complex bill of materials that has several layers and really, actually translates in actual material flow inside the manufacturing company. So when you go to the end level of the bill of materials, you will see the bolts and nuts and similar stuff. But on the high level, it's usually only the selected options. So I'm going to give you a quick example. So this is one of the companies that we support. Is a large Slovenian manufacturer of air filtration devices. And this is one of their probably the simplest products that they produce. So it has 5 or 6 configurable properties. So the customer is able to choose the body of the filter, the filtering material, the gouges, the plugs on both sides, and then also the connections at the bottom. So one simple product, 6 configurable properties, but they have to be able to produce around 110,000 different combinations. So if you imagine what a pain that is for a manufacturing company to keep stock on all that parts and to plan the entire material flow to be able to produce such a product or one variation of the product whenever the customer desires. And this is just one example. The company that we're talking about is producing around 30,000 such configurable products. So when you start, seeing the issue or the size of the problem, we quickly found out that we could really help in a commercial way the companies to actually profit by collecting the data about what is being sold on the market and what is used to or what is good to have in the sales program, and what parts of the options and variations could be removed from the product catalog, so that company actually starts optimizing their material flow and sales process. So one of the three key challenges that we've kind of figured out exist on the market. The first one is, every time you talk about configurable products, they come with a lot of inquiries. So a lot of customers or potential customers send inquiries to the company because they would like to know if they are able to manufacture this, if they have a solution to their problem, what's the pricing for bulk orders and stuff like that. But not all inquiries are converting to orders. So inquiries and quotations that companies prepare is basically a waste of time. So it has to be done. It doesn't add any concrete value to the company, but in order to get new potential business opportunities, company must respond to that. But nobody gets paid to answer or prepare a quote for an inquiry. And when you talk about global companies, those inquiries are measured in thousands per month or year. The other thing is, orders. So pretty much a similar thing. So orders are not all confirmed. Somebody places an order and they place an order for something that cannot be manufactured or is not currently on stock, and the order gets rejected. So it's really a hard or a huge amount of data to manage, and it's usually managed by a small sales team inside the company that has to process all this information. So the first question that appeared for us is how to know which ones are ready to move forward. So how to detect which companies or which customers or which inquiries are ready to be turned into order, and which ones could be thrown away and never thought about again. And the second one is how to forecast sales. So for those of you who know manufacturing world, you get a lot of different solutions from the management in the manufacturing companies, how to forecast sales. And the most usual method that they use is to organize quarterly calls with their biggest dealers around the world and ask them to forecast how much are they planning to sell. But this is usually based on their assumption. They don't have an exact overview of what is going on in the market. So based on the sales forecasting, usually comes the material flow. So we all know that manufacturing companies cannot buy material, just off the shelf. They need to order it in advance. They need to plan it, especially if it's a special material, and they need a way to know what material to keep on stock, what they can afford, to order ad hoc, and how to plan the entire flow. So the solutions that we built, one is already being used in production. The other two are being developed as we speak, and the data is being collected for the entire year, because we need to have a benchmark for currently we are doing supervised learning to feed our artificial intelligence engine that helps to predict that. but we need at least 1 year of data to have enough data to train the AI engine. So the filtration engine, this is basically an engine that was built to track the behavior of customers that use our platform and to be able to score their activities anonymously. So we actually score the deal, not their personal information, but some of the activities, like how much time they spend playing with the options, which type of combinations do they choose, how much time are they spending, you know, checking at the actual pricing or combinations of pricing. This all brings points, and these points are then fed into an algorithm that evaluates their performance based on all the historic activity. And out of this comes a so-called lead score that we use, or sales teams inside manufacturing companies use to prioritize which inquiries are needs to be responded as quickly as possible, and which they are able to throw away because of the massive volume. The second part, the sales forecasting, this one is actually pretty easy but smart. So if you look at any manufacturing company that sells globally, they have a huge network that usually has 4 or more layers for different size of B2B dealers. And what we strive to do is we would like to, or we are building the tools that allow the entire sales network to quickly do the task they need to do. So for example, the end buyer that quotes to the or sells to the B2C customer has a quick and visual tool to prepare the quote or submit an order, where both they and the customer can look at the product, configure it, and it's really a lot easier to do than do it on paper. By doing that, we get all the sales information inside the system, and we can make it available to the manufacturer. So they are actually seeing what goes on in their sales network all around the world in real time, and they can use that information, combine it with the historical data of the sales model, and see what their sales forecast will be. And this is really a huge step into the future for them. And the last part, we have all the data about what is selling, what is not selling, what type of combinations, what type of bill of materials are the most common ones that are being submitted into the system. And we can also start analyzing the material flow. So what material is needed, what needs to be ordered, forecast when it needs to be ordered, and the last part, which components or which options of the product are getting, you know, enough attention from the markets that they are worth keeping in the product catalog, and which can be thrown away if they are not working or not selling. So the final result, currently, we did a measurement on the deal analysis. So we currently measured 67% accuracy based on the real life experience. So we actually tracked what the sales team is doing and tried to predict the which potential opportunities are going to transform into deals. And we are back to the drawing board to make the system a lot more accurate. And for the other 2 areas, sales forecasting, we are currently focusing on detecting drops and spikes of demand. So what happened last year, March, April, and May, where the demand on the markets dropped and the manufacturing industry followed 3 months after that, we are trying to, you know, detect this kind of case in real time, so that the manufacturing companies could react a lot faster. And the final thing is material flow. Like I said, here we are doing analysis where we try to find out what sells and what not to optimize the production process and the supply chain. So these are 3 data-based solutions that are actually getting built into our platform. One is already production ready and it's being sold as an add-on to our main platform, and the other two are currently being tested with 3 of our largest customers that have enough quantity of global operations so that we can learn as much as possible from the data. That's for a short introduction of our use case.
Thank you very much, Leon. Well, I will not give you any question because we are late, and what I see that it is kind of a mass customization interface and all the data behind that, and it is in a face of the customer, and also it is a very helpful tool for analyzing and predicting the sales, and also analyzing and predicting the material flow, and so it's a really nice piece of software. So we go to the next one. This is Miha Primožič. He is a technology project manager from company Domel, Slovenia. Domel is very innovative company, and what is very the company is in workers' ownership. This is quite a rare situation in Slovenia, but they are functioning pretty good, and they are getting every year innovation awards, and they are having a good innovation climate in the company. And so this project, which will be explained by Miha, is one of the results of such a visionary and innovative people working there. Miha, the stage is yours.
Yes, hello everyone, and good day from Domel. Just a second, let me share my screen. Right. Can you see my screen?
Yes, we do.
All right. So our case deals with ensuring safe and stop performing products of our company. To do this, we implemented a testing procedure for each product. Data is binded to product serial number, and because of this, we have historical data for every motor we ship. Domel solutions are sustainable and innovative. Our dedication to innovation has positioned us as a driving market force in several key technology areas, such as universal vacuum motors, brushless DC blowers, brushless DC motors, including permanent magnet synchronic motors. So, about our business case.
I'm sorry, are you moving the slides? Because we cannot see the slides moving.
Could you
you can?
no. From slide to slide, please?
Yeah, I'm moving it.
No, because we are seeing your PowerPoint, not the presentation.
Oh, sorry.
Just stop the presentation and I think move the yeah, okay, that's good.
That's great.
Okay, you see now. We are at the business case description, right?
Yes.
Yes.
Okay, thank you. Sorry for this. So our department deals with R&D and assembly of brushless EC blowers. Each product is checked for safety, tested and controlled, and each step is performed on its own machine, and the results are migrated to the database. The purpose is to ensure 100% control, to distribute safe products, and to ensure that the product meets the buyer's standards. First, we check the motor for electric safety. After that, it goes through a running, and the last step is final control. During this process, a lot of data is generated. Our challenges consisted of defining important test parameters, defining and implementing testing equipment and software, defining measuring process within production process, and data collection. So a bit more of our control process. First, a completed blower goes through electric safety. This ensures the safety of workers as the process continues, as well as the end user. We perform ground bond and dielectric strength test. In a run-in, in a soundproof room with 7 cabinets, which currently accommodates 140 blowers, we run the products on a cycle of 1.5 minutes on and a half a minute off. The cycle repeats for 2 hours while the software records power data. Finally, a report is prepared with average power for each blower. Final control is a quality and specification requirement assurance that are mandatory process throughout production. Performance control is performed on 2 automated machines. These instruments were designed by Stefan Institute. The test protocol is made according to the datasheet that contains all the necessary parameters provided by the R&D. Performance of the blowers is controlled so that everything measured is in the required tolerance ranges. We control electrical parameters such as voltage, current and power, speed and vibration at the different control voltages. We also test vacuum volumes and detect possible mechanical faults. If a parameter does not reach the required values, a red warning light appears. The blower is then redirected to the service station. The blower without defects is visually inspected and transported to packaging. Each serial barcode is scanned and the interface returns the data of performed tests. All the data is drawn from the server and we can check when each test was performed. The interface gives us back the time and result of an electrical safety test, running status and final control status. If the blower skipped a certain operation or it didn't pass it successfully, a red warning light appears. If every motor intended for the pellet positively performed tests, the pellet can be finished and sent to warehouse for shipment. If 1 or more of 3 lights is red, product won't be counted into some of the pellet. For example, 99 out of 100 of the blowers in a batch. The pellet cannot be completed. So, about results. Collected data often proves itself as an asset. A client would inquire about data that didn't matter to them. We can offer that valuable information not only from now on, but also from the already manufactured batches from years ago. We can supply a client with the data from the past. Once, a client inquired for a list of all serial numbers of products in a batch of the shipment. Because we consequently created the data of every product by serial number and saved under batch number, we were able to fulfill the request with no updates to the system. From then on, we send a list of serial numbers to this client with every shipped batch. Our system is designed in a way that is prepared for various customer requirements. If a customer wants an additional parameter checked, we could just implement the measuring device into the final control system. Key findings from this case would be that our process is flexible and enables us to quickly offer our customers free data of their products. Collected data is the basement for determination of quality and safety of the products in our production. Product data as part of shipment builds trust and means added value for our customers. Data is valuable, if not in the present, potentially in the future. There will always be an abundance of data. What is important is the potential in this abundance. We are aware of our data and its potential uses in various processes and business models. That would be all from our case.
Thank you very much, Miha.
Thank you for listening.
I'll also not get my question because we are late. I will just, well, this is a very good case from production that you can see it is added value within production process, and it is added value towards the customers. So we go to the very interesting company also. This is a company, Guardiaris from Slovenia. They are specialized in simulators, and you will see there are specialized in combat simulators. And you will see how they are using this data and how their business model is dependent from the data. Radovan, please, the stage is yours.
Thank you very much. I will share the screen. Can you see the screen now?
Not yet.
Just a moment. Is it now working?
Yes, we see something.
Okay, excellent. Just go to the first slide. Thank you very much. So I will present a case of a training data analytics system. So our company is in the simulation business, in the virtual simulation and training domain. So our challenge was actually to capture the training data and use this training data for a so-called after-action review. So debriefing after the training was actually done. It turned out while we were doing the project, and this is basically an ongoing project all the time, that we had a very positive influence on the future business and on the development of new products based on this kind of thinking and getting results. So we are actually a company in the simulation business, mostly indoor simulation business. On the left-hand side, you can see, let's say, our setup, typical setup within the what we call dome, so the training environment, let's say a radius of 12 meters, where a complete squad of soldiers can train with the real so-called weapon digital replicas or twins. So fully electronic stuff, and we project the simulation environment in a virtual simulation environment, and all the events are then taking place of the battle or something like that. So we are covering really lots of different types of weapons. So let's say anti-tank or anti-aircraft or even vehicle simulators. And later on, we actually expanded this vehicle simulator business also to designing or help designing the new roads or improving existing roads, and then checking the user behavior on the future to build roads. So we are actually building the simulation of the not yet present roads, and then we can check with the human subjects, if you like, how they will perform on the future built road. The specialty of our simulations are that they are tactical, meaning that, let's say, up to 8 trainees can train at the same time performing certain objective or goal within the simulation. So our case is focused on the end of the training. So the case of the showing the training analytics. So what was happening during the training is, so it's a piece of software that takes a lot of data from the events that happened while we were training. And then we use this data in a, let's say, a straightforward presentation forum to so-called instructors. So the managers of the training, so they're usually they are actually the soldiers that are that are higher in rank or leading a squad, a platoon or something like that. And then they evaluate how the trainees or the soldiers performed. And so task performance is, you know, making the objective at the end or within the time, or were you the best? And then the next level is actually for the military to select, you know, best performing guys together so that you can really grade several teams and put them together so that you have best results at the end of the, let's say, perform certain objective. And what is interesting is that we collect data from various sources, meaning one are the events obviously on the weapon handling of the weapon digital replicas, and the other are the events that are taking place during the simulation. Let's say tank is coming just in front of you. So what was your reaction time? Or you were in vehicle and a sign happened to be just around the corner. So again, were you looking at the sign or were you looking at the, you know, zebra going through the crossing the road or something like that, if you're in Africa, of course. So I would like to point out that the complete software solution that is in-house, of course, is based also on the simulation that is also in-house done. So the simulation graphics engine, and most importantly, the so-called SAS module is a piece of hardware equipped with cameras and gyroscopes and similar sensors that helps us navigate within the three-dimensional space. So the objective was actually to have this post-training analytics, but it was very important that from start we are, of course, interoperable with all the existing hardware that we already have. So with all the existing weapon digital replicas and the future stuff. So we actually described and devised an API that is based on a certain protocol. And then we are actually also able to expose this API so that we are interoperable on the international level. So we have shown on a couple of occasions that we can bind, if you like, and communicate with simulators from other vendors and interoperate with data exchange. And of course, so this is basically a tool that helps evaluate the instructors, the trainees, so how they performed. The real value of the tool is that you have a data for the, let's say, conscript that just came into the army and he starts training, and then you can really follow his proficiency through the time, maybe even through, you know, years. And after several years, when you have again exercises or something like that, you can check again how he's performing on the same or similar tasks. During the development, we generated a couple of patents. Of course, we generate also a lot of data now. I must emphasize here that since the complete setup is in the hands of the end customer, in this case, let's say some Ministry of Defense or something similar. So all the data that they generate, it is their data. So we don't have access to this data. So this is some special case. And they use this tool, you know, for their own purpose. What was very interesting is that the whole concept was developed by a young team, I would say. And it was very, very nice to see how they concurrently actually produced, you know, all the solutions from mechanical, electronics, hardware, and software, of course. And they were working together. And it's very important that you have management in place in the company, you know, that really nurtures this kind of cooperation in the team. So this is really crucial. So on the lower left-hand side is part of our solution. So on the replica of the weapon, you can see attachment of a so-called SAS module. So this is module that does the orientation within the 3D space. So we can really detect how this weapon was handled and moved around while you were training. And to back this up, we have several cameras around, and we do so-called skeleton recognition. So we can mathematically actually evaluate how you were moving. And of course, we are also using eye tracking solutions for driving simulators or some similar simulators in our designs. And you can imagine that then we integrate all this data, fuse all this data into something meaningful for the presentation. It turned out that when we started, so the debriefing sessions after the training, they were quite rudimentary. Then we started with the, I would say, ABC of the first features, and we quite at the beginning of the project already shared what we have done with the potential customer. Okay, we already had the customer, but then we wanted to present to them, look, we have something new. Maybe you are also interested in about new developments. And what happened was that this triggered actually the avalanche of new orders, if you like, so new business potential. And somehow we have put this incremental innovation into place all the time. So we are listening to our customers, so they give us feedback, and then we evaluate when we go into the new production, and we just put that on the market. So you can imagine that these kind of simulators are, of course, not a massive number of products are not on the market. So this is really, I would say, small scale production. And that's why we can really afford to do this kind of very high speed spin of the designs. And of course, I would like also to emphasize that you must be patient before it really breaks, is a breakthrough on the market. But what we did was we trusted, and especially the management trusted into the superb engineering that we have in the company. And of course, in the meantime, you just deliver the product and even have some IP rights already available. So thank you very much.
Thank you very much, Radovan, for this nice presentation. Well, you will also not get my question because we are behind the schedule, but we will at the end try to ask all those companies doing presentations with some questions which comes also from audience. Well, the next one is Peter Zupanc. He's developer at a company Result, and he will provide also a good presentation about combining GDPR data, personal data, and data used in a business model. Please, Peter, the stage is yours.
Thanks. So do you see my screen?
Yes.
Okay. Let's just check presentation if everything is all right. So do you see also moving slides?
Yes.
Okay, great. So today I would like to present a very specific case. Our company is actively involved in its development and maintenance. Since there is a need for privacy, confidentiality, and I'm bound by non-disclosure agreements, the name of the entities taking part will have to remain undisclosed. The nature of the entities, however, will shed some light on seriousness and scale of sensitive data and financial data that is covered by GDPR and other internal data protection policies. In our case, we have two large global companies. One of them is leasing company, which hires our expertise and knowledge on various IT fields. The other entity is a global corporation, with a global presence. But in our case, we're dealing with the core company in Germany and its subsidiaries. The reason for sharing the personal data between these two entities comes from a desire to reduce the overhead, paperwork, human error, and increase the automation. There is a strong incentive on both sides to make the business process as seamless as possible, as to minimize potential errors and minimizing costs. Corporation employees have an option to apply for a company car for their personal use. The selection of vehicle depends on their employment contract and other agreements. The business model is based on corporation employee data, corporation's internal business processes. Personal data is the main pillar of the business model. Without current and valid data, leasing contracts cannot be issued. Rules set by corporation impact individual employees' purchasing power and limit vehicle selection. User data alongside with rules set by corporation and adding the leasing company's own processes and requirements define minimal and maximal value for an individual leasing contract. At the end of the processing, the most suitable vehicle option is calculated and offered to the customer. So the leasing company has a special dedicated portal where the employees of the corporation have an option to order cars, which are then subject to a leasing contract. To facilitate a smooth and streamlined experience, the backend system provide and process all information needed for the whole process, from the user eligibility to create a new offer to whole leasing contract lifecycle. The system handles both individual and corporate fleet contracts, and in order to achieve data concurrency, regular data synchronizations and exchanges are scheduled between both parties. Data is then transferred via secure connection between dedicated machines, which IP addresses are whitelisted and do mutually authenticate themselves with RCA keys. Personal data is sent by the corporation with SOAP or HTTPS requests, and it's then funneled into a dedicated database where it's encrypted and stored. Access to this database is strictly limited to a handful of employees and database administrators, and the data can only be accessed by a special microservice. So because the corporation is incorporating leasing contract values into the employee salary calculations, the leasing company has to provide monthly reports. The same principles for the incoming data apply for the ongoing data. Personal information is decrypted for processing purposes only and then forgotten. So it's paramount that this data is not logged anywhere, either on machines where the service is actually running or other systems like Elk Stack. The GDPR here poses a bit of a problem for development and production incident investigations. In both cases, and especially in production incident investigations, a great care has to be applied to data handling, where we need to make sure that all GDPR relevant data is anonymized before transferring it. out of production environment in case that using GDPR data is unavoidable. Consultation with company's GDPR officer is needed, and all steps of deleting traces of used data needs to be undertaken after development or incident resolution. So challenges, as it was indicated so far, the main purpose of GDPR implementation is to keep personal data secure and out of reach of prying eyes. This is and can be very challenging when dealing with a bulky system used by all parties involved. It requires a huge amount of planning and foresight to manage data flows, data processing and storage. The challenge can also be separated into 4 parts, like security, so secure data transmission between companies and data encryption during whole leasing contract lifecycle. Then for access, we compartmentalization and limiting physical access to the database. Centralization, personal data should be stored in a way to easily facilitate GDPR. Intellectual property, so safeguarding customers' intellectual property. In our case, the leasing contract lifecycle is a business secret. Solutions which we came for. Our personal data should be and stay encrypted, whether it's located in a database or as a batch files, writing files waiting for transport or processing. Data should be transmitted via secure transport protocols like HTTPS or a secure FTP. Access to personal data should be limited as much as possible. Compartmentalization, departments who do not need to deal with sensitive information should not have to access it. Strict database access policy enforcement, so access to the database itself is limited to a handful of database admins. Data access traceability, so any access to the data should be logged and its usage should be traceable. Centralized approach enables quick response in case of GDPR inquiries, and the data generally easier to maintain and secure by limiting access to select administrators. So we have a dedicated database for personal data. So personal data is stored in a separate database, reachable only by some specialized microservice. Dedicated microservice. Via this service, the employees and automated processes can query the personal data for business purposes, and interactions are logged. To safeguard business processes and internal data flows, non-disclosure agreements are signed, so NDAs, between leasing company and corporation, and between leasing company and external company. In this case, is this our company? All employees in all entities involved are required to sign an NDA before employment. Results are that data is secure, personal information is encrypted with randomly generated key for each scheduled data synchronization. Data as a batch files and batch files are transferred securely via HTTPS and SFTP respectively. Sending and receiving machines IP are whitelisted, and mutual authentication using public key is enabled. Limited access. Unauthorized employees do not have direct access to the person database. Personal data can be queried by microservice, which logs the necessary usage parameters for audit purposes. GDPR is also satisfied, which means that personal data is a single source. Dedicated microservice enables audit of personal information requested by its owner and give the owner the right to forget option. Handling the GDPR data on small or large scale, it's not fundamentally different. Larger systems usually encompass more subsystems, which all have a possibility to leak personal information, and thus it's harder to identify them all. With careful planning and due diligence, everyone can rein in loose data and eventually fully comply with GDPR. Our key findings. So here are some of our key findings, which we also kind of mentioned it in our previous slides. So business must define clear goals in collaboration with the IT department. A very robust testing regime must be agreed by both parties. The documentation must be clear and concise. NDAs need to be fully enforced. The need to know policy does not hinder business operation, and as long as the data can be uniquely identified by other means rather than personal information, it is important to have a clear picture what and where GDPR is. Having it centralized, meaning makes the audits and deletions much easier, and encrypted data adds another layer to privacy. So thank you for your attention. Because of the limit we already have passed, if you have any further questions regarding this topic, feel free to contact me through my or company email. So thank you.
Thank you very much, Peter. It was a very very good insight of security background when you have to deal with the GDPR data with the other data which are at the basement of the business model, and all the measures you have to take that you provide the real security in the data transfer, in the data access, and also the ability that this owner of the data could be forgotten. So for sure we will send you questions, because I have put some on my list, and I will be very glad that you will answer that. So we have the last one in this section. This is Andrea Buccoliero. Well, I hope, Andrea, that
Good evening.
That I spell your surname okay or not?
Yes, perfect. Absolutely
okay,
perfect.
Thank you very much. He's a project manager of R&D from Gruppo GPI from Trento, Italy, and he will also have a GDPR problem, and for application which is serving 8 million patients in Italy. So Andrea, we are all ears. Thank you.
We are just let me know if you are able to see my screen.
Just a moment. Yes, we are.
Okay, perfect. So first of all, thank you for having me. It is a real pleasure, and thanks to all of the speakers and the very interesting talks. Today I'm going to talk to you about a specific case which regards the development of a predictive agent for the health risk of elderly patients. But before going into deep with this specific tool, with this specific component, I just wanted to give you a few information about our group, because we are a multinational group based in Trento, which has about 60 sites in Italy and about 50 abroad, and focusing on different kind of services and different business units that provided solution technologies, softwares, especially for the healthcare system and the social system, with different kind of direction, let's say. The department to which I belong is the R&D one, which is mainly focusing on the virtual care, let's say, topic. And in fact, we developed and we implemented in almost of Italy in the last year one suite which provides a modular architecture of components that enable the healthcare system to provide care path to a digital environment. But today I'm going to talk to you about a specific challenge, a specific, let's say, case we manage, because within our virtual care suite, which is made of telemedicine, televisit, enrollment modules, and electronic health records, we also wanted to add some tools that are based on artificial intelligence. Even if we are mainly going into 3 different directions with AI tools, because we are moving into the stratification and machine learning algorithms, and in the remote diagnosis, so in the detection of pathology. This specific case I'm going to tell you today regards a study which was executed on a really big data set, which was made up about 8 million records belonging to 20,000 patients with a depth of 10 years. This giving us an history of the evolution also of their individual assessment, health assessment. But coming back to who we are technology expert, we are AI expert. We wanted to provide a solution which was based on a specific challenge. Once we have a big number of information, once we have a lot of information, and especially for the healthcare sectors, we have also different kind of sources for this information. Just think that in Italy we have 20 regions with 20 different ways of collecting data, health data. We want to identify by running a pattern recognition model, computational model, which were the irregularities that were again repeating when analyzing the health profile of a patient. For doing so, together with the clinical expertise in a specific project, we identified 4 main targets, which are glucose, creatinine, diastolic pressure, and systolic pressure. And out of this pattern recognition analysis, let's say, we were able to identify which were the features, the parameters, mostly impacting the target variable, which was suggested by the clinical side. This was really something important, because first of all, we, after having trained the algorithm, we decided to, of course, test it, and we had a really high level of accuracy of prediction. And this regards, let's say, the methodology. But in order to go from a research approach to a market approach, we decided to introduce this methodology into an agent, which you are able now to see is just the screen of one page of our web application, which is the suite I was telling you before. And there, all of the persons that are part of the care team are able to to give as input a number of variables, which are the usual variable of laboratory analysis, and execute a live prediction of the complex risk of the person. But this gives 2 kind of advantages. On the one side, it gives information, of course, on the risk. So the doctor or all of the members of the care team are able to start a care path before the occurrence of any symptomatology or negative occurrence. But on the other side, by understanding which are the parameters that impact specifically some targets, it may also operate on the behavior on the patients and work in order to transform the risk, the high risk level, into a moderate or lower risk. This is my presentation. I just been really quick, but if you have any question, please contact me. There you find my contacts, my mail. Thank you so much.
Thank you, Andrea, for your quick presentation. We are really behind time, almost half an hour. And for sure, you will get my mail with a question, because I have prepared.
Yeah, there are many issues still to go in depth. Yeah. Also for compliance.
Yeah. Okay. So I will go to the next session, and this session is mainly advisory session, because I would like to invite our keynote speaker, so keynote speakers, experts that you have heard, and all these companies with certain business models and combining with the data. And I would like that you give some a kind of advices for what to do, how to do, and what you have to take care, and so on. Mr. Veršič, could you just put some final words about that? You are the first one.
Thank you, Rudi. Yeah, what is important for me, and I hope also for all of us, that we should share the data to create some new value. And what is the quite open issue is ownership of the data, because we are creating so much data, and I think this is the challenges in front of us, especially if we are talking about the industry. For example, in the cars, there is so much data created by the users, and the question who is the owner is still not solved yet, I think. Maybe this short version of mine. I'm thinking what is the challenge in front of us, and I hope that this project will put some clarity about this ownership of the data.
Yes, I am sure about that, because there will be even more and more data which will be available, and which will be and we will have to solve this question quite fast, because we need a straight resolution of this, because otherwise the business models will not work as we planned.
Yes.
Yes. Thank you, Aleš. Well, Matija, your final words for the audience.
Sure. I will try to have a short presentation on that as soon as I find. I think it's this one. Can you see the slides?
Yeah.
Okay. I will try to be quick with this. I think the most important thing I want you to know is that there is no one business model when it comes to mixing open source and a commercial entity. So there's no one way how to commercialize open source, or how to act when you have open source involved. This slide, I borrowed the decision metrics from a book called Principles for Industrial Open Source. It's a really great handbook. I have a link to the free PDF at the end of the slides. If you can, you probably don't. Can you see my browser now? No.
No.
No. Okay. There's a link. There's a link in there. Also, at the end of all my slide decks, there's a lot of links that are useful to look at. But if there's one link you're going to click, it's that one. So the thing is, because as we already heard today, there are so many different companies with so many different products and services that are being paid, and I'm pretty sure all of them use open source somewhere. So how you get from open source to money is very mixed. It can be it's the data, it can be that it's the software, it can be that it's supporting services, etc. So to optimize your decision, one of the ways to do that is to figure out what's the commodity in your service or in your product, what's a qualifier, and what is your differentiator in the market. So if it's a commodity, if it's freely available, everybody has access to it, there's no reason why you should write that yourself, why you should spend your own resources to do that. And if it's available as open source, there's no reason, or open data, there's no reason why you would pay somebody else for a license or to do that for you. So as a commodity, it makes more sense to just use open source that's available. For the parts of your solutions that are qualifiers, which basically, for example, if you're in the AI business, your AI engine would be a qualifier. Like every AI needs an engine. So in that case, if you can find it as an open source, it makes sense to just buy it, to just grab that. If you have to pay somebody for existing stuff, there's probably something around. So I would say like something around here is a good place to be if we're talking about the qualifier. But when it comes to the secret sauce, it doesn't make sense. If you're going to release it as open source, then you might lose your market advantage. On the other hand, if you can buy it, then it's obviously not your differentiator, because it's available on the market, so it's not unique to you. Why would somebody pay you instead of your competition? So it makes sense to keep it to yourself as your market advantage. But here's the thing is that the important part here is I think that we're not talking about the product or a service here. What I think you need to do is you need to chop up your product or your service into smaller components and smaller services and figure out which parts and which components of that are a commodity in your use case, which are a qualifier and which are a differentiator. So again, the book, Principles for Industrial Open Source, go get the PDF. That it's very quick, it's very short and very, very concise. One of the best books I've read on this topic in a long, long time. So there's also some best practices out there when it comes to using open source in the whole supply chain. When it comes to technical best practices, software package data exchange is an ISO standard that is like the software bill of material format in the industry. And it's also a standardized language notation and unique license identifier standard for just describing open source compliance information and copyright situation, as well as technical information in any software package out there. So when you produce bills of material, SPDX is the format to use. Where you refer to licenses, use SPDX IDs or their license names. A solution on top of that is the reuse software project, which is how you mark your own code appropriately for that everybody knows who the owner is and what the license the code is under. I'm not going to go into details because it's like literally 3 very, very simple steps and there's tooling involved, and it's a very useful website. Just click on the link. This is basically how the outcome looks like, as you have a SPDX standard copyright tag and an SPDX standard license identifier with the ID, unique ID in it. And that's all you need to use in every file. That's basically it. Because figuring out which licenses, which packages and which files are under which licenses is a lot of work. There's obviously a lot of tooling out there. Luckily, most of the tooling you need is by now also open source itself. This is a screenshot, or this is a graph from the open source tooling group that has like a huge page link down again. where they have a list of all the tools that are available. You don't need something as complicated as what you see here, which is basically like the whole tool chain in a CI/CD environment with everything in and around it. That's how Siemens does it. If you're not as big as Siemens, you're probably going to be okay with just 1 or 2 tools. Here's a list of with links to tools that I find pretty useful in this context. But obviously, there's also best practices when it comes to business processes, not just technical standards. So another ISO standard is the open chain, which sets the minimum compliance, minimum open source licensing compliance standards in the supply chain. So it means that a open chain certified organization, if they're a supplier to somebody else, their client or their customer knows that organization has policies, processes, and knowledgeable people in place to handle open source and handle open source compliance issues and questions should they arise. I warmly recommend to check out the link, even if you're not interested in self-certifying. So you can self-certify and it's for free. But even if you're not interested in that, they include a lot of training materials that could be very useful to figure out where you stand in the open source compliance obligations that you need to meet. And at the end, I mean, it's not just compliance. It's something that I see a lot of organizations now have figured out, a lot of bigger companies mainly, that just doing the bare minimum that the law require or the license requires you is needed. But they see that if you treat your open source suppliers or your open source upstream as a critical supplier, because let's be honest, if all of open source that we know suddenly disappears, we're in a really bad spot. So if all the open source disappears right now, I think most of our companies are in big trouble. So you need to treat them with care and interact with the community. And although in the short term, it's an investment, upstreaming your fixes and patches and collaborating with the upstream in the long run reduces research and development costs. And from what I see is a lot of companies have figured that one out in the past few years. And that's something I want for you to think about and hopefully care about as well. And that's it. And as I said, there's links at the end of both of our slide decks. And this is the important one. That's the one you really, really, really need to click on.
Matija, thank you very much for this valuable information and advices regarding how to use and what to take care and what is available regarding the tools and standards. So I will go to the last one because Mr. Lipnik he had a lecture, so he will not be with us for his final words. So I will give the stage to Stefan Fischer. And Stefan, please, your recommendations.
Sure. Well, data is valuable, and a portfolio of data sets can be worth more than the sum of its individual sets. Same as I said for patent portfolios. And data set portfolios can also be financial instruments, and they can nowadays easily be converted into investment vehicles using tokenization and other modern technologies. So my recommendation is to use these techniques to convert data sets into financial instruments, into investment instruments, and develop new innovative business models, and use the classical ones to sell these to clients. And I wish there was a biotope of tools and standards for data sets as there is for open source software.
So just my question, what do you think is the greatest barrier to obtain this?
Well, the collaboration, the courage to say I put my data set together with data sets of other entities, and I create more value by collaborating with other companies who may even be competitors. That is probably one of the barriers, but there is some synergy to be developed.
Yes, I think this is a very, very important message. So collaboration and sharing the data brings the value not only to those who are sharing the data, but also to those who are accepting the data, and also the society.
Exactly, yes.
Okay, thank you very much indeed for experts for all your contribution, and all the presenters for a very, very informative afternoon. So we are 16 minutes late, so I'm very sorry for that, but I think that information we got and all the presentations were so valuable that this 16 minutes spent was a good investment of our time. What else I would like to say is that we would like to invite you to leave a feedback on this workshop. You will got the link here. You can also do it now. Just scan this barcode, and the triad of the workshops come to the end. So we have heard about digital IP and data agreements, legal aspects of digital IP protection and management, and data-driven innovation and exploitation. So those I see that some of you were with us on all three workshops, and I really hope that you have gathered insight about how the value of data and how the IPR is also depend from some decisions of the companies, and that what the legislation will bring to us. And this is certainly a very exciting experiment, and also very exciting environment in the future, where there will be a plethora of business models and a plethora of new applications and new added value for coming from the data. I would like to thank also to all of you once again for your work, and also for the team in the GoDeep project. So from Trentino, Elisa Morganti and Stefano, and also from the Switzerland, Pascal and Michael. And so we wish you a nice afternoon and evening, and so thank you very much once again that you have been with us.